Hi everyone, and welcome to the EDA Summit 2024. I hope you're having a good time. Today I'm going to be talking about harnessing the power of Lambda response streaming for data retrieval. I'm your speaker, Sandeep Kumar. I work as a principal solution architect at Anstech. I have about 6 years of experience in developing serverless applications, and you can reach out to me in any of my social handles. So let's get started. The loading time and its impact on user experience. So any website, the longer it takes for you to load a particular section of the page or the entire page, it has a direct impact on how the user is perceiving and using your website. So these are some of the metrics that affects how the user is interacting with the website. So first is the abandonment rate, which basically means how long the user is going to wait until they're going to stop using your website and go to some other competitor's website. So it's also called as bounce rate, which increases by 32% when the loading time increases from 1 second to 3 seconds. So these are some of the stats that are taken from a Google survey. You can go ahead and look it up online later. The other thing it also affects is the revenue. Now, if your website is built to have ad revenue, or if your website is going to showcase some products that the user needs to purchase and complete the transactions on, the slower your website loads, the lower the conversion rate is. So people are not going to use your website, or people are going to go to a competitor's website who has a faster loading rate, rather than just sitting and waiting for your website to complete loading. Now, at our current technological rate, speed is everything. So if your website is slow, it automatically creates a perception that your website is of low quality or the engineering could have been better. So these are some of the things that affects your user experience based on how your website is loading. Now, irrespective of how good you designed an API call, when the API call is getting executed, you're going to put some kind of looker on top of it. You can make it fancy, you can add graphics to it, you can make animations. It doesn't matter. At the end of the day, it's an API call, and you're masking the API call. While your website is showing a loader, this is what your client is looking at. The client doesn't care about the time it takes to load. They just want to see the result as soon as possible. So the longer it takes, the faster the client is going to go for a different website. One thing to always remember is no matter what, faster is better and less is more. Let me tell that one more time so you can ingrain it. No matter what, faster is better and less is more. So how do you overcome these issues? So that's when we start this concept of instant response. Everybody wants to see things on the website as soon as possible, and we're going to see how we'll be able to do that. How does this change of having an instant response affect user experience? Of course, it improves the user engagement. It creates the perception of quality as well. It improves the performance. It reduces the bounce rates. Basically, the user is still sticking to your website rather than going to somebody else's website. It also affects the SEO rankings. Yes, the SEO rankings also increase when your website loading time is faster. And it creates human-like conversations. So, for example, if you take ChatGPT, let's say instead of loading character by character, it just waits for the entire API call to complete, which takes about 2 to 3 seconds, and loads the entire conversation. That is still good given the amount of work it's doing, but it feels more human-like when it is loading per character. It looks like it is streaming or it is typing rather than just waiting for the API call to complete. So where does this help? It helps in chatbots, of course, chatbots like ChatGPT. It helps in web applications where you're loading large data sets to the front end, and in any other applications where you're using large images or when you want to query a large database result, any kind of analytics platform. So all these places where there are large payloads and you want to stream it to the front end or to stream it to any other application, instant response helps. So what is Lambda response streaming? Lambda response streaming is a functionality of AWS Lambda that was released in April 2023. Unlike the traditional invocation patterns where you have something like an API gateway connected to the Lambda, you can invoke the response streaming using the function URLs. So with the function URLs, you can directly connect to the Lambda bypassing any kind of middleman like API gateway. Of course, now that you have excluded any kind of third-party services like API gateway, you can directly connect to the Lambda, which also reduces the overall turnaround time. And with this, it also increases your TTFB, which is the time to first byte, which basically defines how fast the first data set is being rendered or is being sent to the front end. Now, Lambda response streaming enables two methods, write and pipeline. Write method is used for data sets, and pipeline is used for large data sets like images or any other custom media content. Currently, Lambda response streaming is supported in Node.js 14.x and higher runtimes and custom runtimes. So now let's come to the code changes that are required compared to a regular Lambda versus a Lambda that needs to be configured for response streaming. So the first change is your handler function needs to be wrapped in a decorator called AWS Lambda.streamify response. This exposes a stream object, which is called response stream. Now, using this object, you can expose the main methods, which are write and end. Now, what does these do? So using the write method, you can send the data from the Lambda to the front end or any other application receiving it. Now, the only criteria is that you need to send it in a string format inside write. And once you have done sending all the data from the Lambda, you need to end the execution of the API call using the end method. Now you can see that it has very minimal changes. It's not going to take a lot of time for you to refactor a Lambda that was written in a regular format into a response streaming format. And this example is for Node.js. If you want to do it for, say, Python, you'll have to build a custom runtime with a Docker and you enable it from there. Now let's see the direct comparison between a regular API versus a Lambda response streaming API. Now this is how your regular API looks like. So let's say you have a React client on your front end, and that's going to initiate a connection to the API gateway. The API gateway is in turn connected to a Lambda. And in our case, let's say the Lambda is loading a large data set from DynamoDB. Now inside the Lambda, you're going to write the code to query the database. And if it's going to have a pagination based on the last retrieved key, you're going to run multiple calls to the DynamoDB and get all the responses and then send it as a response from your Lambda to API gateway. API gateway sends it to the client. This is how the traditional API works. And in most of our event-driven architectures, this is what we've been using. But this is how the response streaming API works. Now, you have the React client that directly talks to the Lambda using the Lambda URL. Now, inside the Lambda, you're doing pretty much the same thing with respect to DynamoDB, but at the end of every query that you're doing, you're sending the response to the front end rather than waiting for the Lambda to get all the data from DynamoDB. So instead of one single response from the AWS Lambda, you're continuously sending data back from Lambda to the front end. So the front end can load it more progressively rather than waiting for the entire data set to be completed. So what are the advantages of using the response streaming? So by default, the regular Lambda supports a response payload of up to 6 MB. But when you configure it for a response streaming method, you can send up to 20 MB of data, and that is still a soft limit. So that can be increased. Minimal time to first byte, of course, because you have eliminated other overheads like API gateway is going to be much faster, and direct connection to Lambda also means you control what kind of data you're sending, how much data you want to send, and the mechanism of any kind of initiators or controllers, everything can be done through this connection. Now, other advantage is, like I said, the connection is controlled directly by the AWS Lambda. So once your execution is complete, you can stop the execution by doing an end method. You can control it. You can send other information as well. You want to talk to DynamoDB, you want to talk to any other data sources. All this can be cumulatively done within one single Lambda. You can send different kind of data sources to the front end. All that is possible when you're using the response streaming payload. Some things that are good to know that you need to keep in mind before implementing the response streaming. Now that you don't have the API gateway, the security mechanism is via IAM. So you use IAM policies and secure the authentication. And the API call that you do for the Lambda user should be a sign request which has the temporary access keys for you to access this Lambda. The other thing that you can do is you can combine it with a CloudFront. So meaning that you have a CloudFront distribution and you create a specific path and you assign that path to a Lambda URL. Now by accessing that path, you access the Lambda URL. In CloudFront, you can configure the edge functions. In that, you can configure any kind of custom security that you want to put in place. And currently, the Lambda response streaming is supported by Node.js 14.x and above runtimes. And you can also configure them in any kind of custom runtimes. One thing to keep in mind is the first 6 MB of data that you send back from this Lambda is free, which is how the regular Lambda also works. But once any data beyond that is charged at $0.08 per GB of data that is sent from that particular region. Next thing to keep in mind is the bandwidth. So the first 6 MB of bandwidth, which is the default element, is sent at maximum speed. But after 6 MB, there's a cap of 2 Mbps for the data that is being sent from the Lambda. Next thing to keep in mind is you use the right method for any kind of progressive data, like a DynamoDB query result, or there is some kind of timeout. You need to wait for a couple of seconds before you send the next data. For all those sort of progressive data that you need to send, you use the right method and you use the pipeline method for things like images or media content, any large static content that is already available, but you want to send it as a stream. So in those places, you use pipelines and you use writes or query results, any kind of progressive data. Now, let's go to the demo. Yeah. So today we're going to be talking about the DynamoDB use case. So what is happening over here? On the left side, you're seeing a response streaming API where the React client is directly talking to the Lambda URL, which is doing the operations on the DynamoDB. On the right side, you're seeing the React client talking to an API gateway, which talks to the Lambda and then talks to the DynamoDB. Now here you can see the time to first byte, the left side, followed by the total API time it takes for the entire operation to complete, and the number of DynamoDB records it is fetching out of the system. Now, in this example, it is fetching about 4.5 MB of data, but that again can be increased based on the requirement. Now, let me reload the screen and you'll be able to see the differences. Now, the stats that you're looking at right now is for a cold start. And even in the cold start, you can see the total time is lesser than total time of response streaming API is lesser than the actual Lambda. Again, because it bypasses API gateway and it's a direct connection. So you're avoiding all the overhead that it requires. And the main thing to note is the time to first byte, which is more than double of a response streaming. Now let's reload to see how a warm start looks like. So you can see in half a second, it has already loaded the first set of data. And from a user experience perspective, the table has already loaded. The upcoming data is just loaded behind the scenes. So the user gets a seamless experience as if the front end is already completed loading. Let me just reload it again so we have a better picture. Yeah. So this is how it feels when you have a response streaming versus a regular API. The user experience is unmatched, and the way it looks and feels in the front end is completely different from how we do it in a regular API. With the added advantage of being able to send larger payloads and everything, it is way more easier and better for user experience to use a response streaming API. So if you want to try out the example demo that I showed, you can go ahead and clone the repository. The repository is configured with a one-click deployment. You just need to update the access keys and put some parameters, then you'll be able to deploy it in your account. And you can test it yourself and see how it feels to run the application. If you're curious to know more about this, we have also written an AWS blog, a partner APM blog. You can go ahead and scan the QR code or navigate to the link specified here to read more about how the response streaming is configured, especially with DynamoDB. So that's it from my side. Thank you everyone for joining the session. If you have any doubts or queries, feel free to reach out to me on any of my social handles, or you can mail me at sandeep@anstack.io. I hope you had an informative session. Let me know any sort of comments or feedbacks that you would like to provide. Thank you.